21st, a body of mass 2 kg has an initial speed of 5 meter per second. So initial speed is u is given as 5 meter per second. A force acts on it for 4 seconds. Time is given as 4 seconds in the direction of motion. The force time graph is shown in the figure. So on y-axis force is taken, on the x-axis time is taken. You are asked to find the final speed of the body. Children, we know that the area under force time graph gives impulse or change in momentum. But here in the question they have asked us to find out the final speed. Final speed means mass into velocity. Okay. So in that aspect, first of all, try to find out the area of the given graph. So here if you observe, this is a triangular portion and here it is rectangular portion. So the force time, a force acts on it for only 4 seconds it was given. So here in the time, in this graph, time up to 8.5 seconds is being given, but you need to find out only that particular velocity when the force acts until 4 seconds. So that means you no need to bother all this area, only you need to focus on this particular area, because up to 4 seconds whatever the force has been applied, and because of that force whatever the velocity it has gained, we need to find out. So children, as we know that the area under force time graph gives, what is that children? Area under FT graph gives impulse or change in momentum. Impulse or change in momentum. So this part is known to you children. Area under force time graph gives impulse or change in momentum. So that means area under FT graph. What is the area under FT graph? This is force and this is time. So first portion, if you find out, this portion area means this is a triangular portion. Triangular portion means half into base into height. What is the base children? 2. And height is something around here 4. So half into base into height. This portion area we finished. Now coming to the second area. Second area up to 4 seconds. Up to 4 seconds. So this is of the form rectangular form. For a rectangle, length into breadth. From 2 to 4, what is the length children? 4 minus 2 is 2. So 2 seconds into height. Height is taken as 4 newtons. So 2 into 4. This portion is 2. 4 minus 2, 2. And this portion is 4. So base into height must be equals to change in momentum. Change in momentum means mass into V minus U. So based on this formula, you have to solve the required value. Okay, well, so let us try to solve the same after substituting children. So this 2 and 2 gets cancelled. Now you are left with how much? This is 4 plus 4 into 2 is 8 equals to mass of the body is given as 2 kg. Final velocity you are asked to find out. Initially it is moving with a speed of 5 meter per second. So this is 5. That's it children. So try solving this. 8 plus 4 it is 12 equals to 2 times of V minus 5. Or if you bring this 12 to the other side, 12 by 2 is equals to V minus 5, and this goes 6 times. Hence we found that 6 is equals to V minus 5, or bringing the minus 5 other side, 6 plus 5, that is 11. Hence we found that final velocity V is equals to 11 meter per second. Hence the correct option is option number 2, that is 11 meter per second. Okay, well, now moving to the next question. 22nd, a force time graph for the motion of a body as shown in the figure. This is also force and time graph. Change in linear momentum between 0 to 6 seconds. This is 0 and this is 6. The complete time, during the complete time, you are asked to find the change in momentum. So for this we know that again the same concept, area under force time graph gives change in momentum. So this part is clear, children? That's it. So area under force time graph gives change in momentum. So force time graph, if you observe carefully, okay, so this is a rectangular portion, okay. So for that rectangular portion, if you observe carefully, area of this rectangular portion is base into height, length into breadth. And if you observe this area again, yes, this is also rectangular portion. So if you suppose this one as area 1, the first one as area 1 and second one as area 2. The area under the graph, if you would like to find out first portion area, how much, children? Here you have already 2 is there, this is minus 2, and below the x-axis means that is minus 2 into 2. For this portion the area is let me tell you, area under the graph means area 1 plus area 2 is equals to change in momentum. Change in momentum means mv minus mu. So this must be the formula and you are asked to find that change in momentum. So instead of mv minus mu, I would like to write it as delta p. Okay, our final momentum minus initial momentum, that is pf minus pi. For your clarity, pf minus pi is nothing but your change in momentum. So area 1, what is the area of this, children? Area of the portion, length into breadth, 2 into minus 2 plus area 2 is nothing but from here to here. Here it is 2 is there and here 6. From 2 to 6, how much is that, children? Time 2 to 6, what is the time interval? 6 minus 2, that is 4, into height is from here to here, the height is in force newtons. How much newtons? 1 Newton. So minus 2 into minus 2 is minus 4. 4 into 1 is 4. Hence change in momentum was found to be minus 4 plus 4, or minus 4 plus 4 is 0. Therefore change in momentum is 0. Change in momentum is found to be 0. Hence option 1 must be the correct choice. 23rd question. An object of mass 3 kg is at rest, initial at rest condition. A force F is equals to 60 square I cap plus 2t j cap Newton applied on the object. So force is applied. You are asked to find the velocity after 3 seconds. Children, we know that according to Newton's second law, the rate of change of momentum is directly proportional to the net external force applied. So F equals to delta P by delta T, and for smaller portion it is given as dP by dt according to Newton's second law. So we can also write this dP as F into dt. In order to find the small portion, small change in momentum is nothing but the product of force and that small time interval. If I would like to find out the total momentum, then we need to integrate both sides. That means the total momentum, in order to find, means you need to integrate dP. So integration, you already aware of that integration. So integral dP equals to integral of F dt. So you're asked to find the momentum. Momentum is nothing but integration, to find the integration overall, okay, equals to, if you take the integration portion for this, here also integration. Hence the value of P is given as integral of F dt. The value of F itself is given as 6t square I cap plus 2t j cap. So this is the value of force I replaced, and now with dt. Okay, children. Well, momentum can be written as mv minus u equals to. So integration for the whole entire term. So this integration is for both 60 square I cap, whereas for 2t j cap, and bringing the dt inside, then it will be 6t square dt I cap plus 2t dt j cap. So integration is carried for whole thing. And up to what limit, children? The time is limited for 0 to 3 seconds. So the velocity of the object up to 3 seconds it is been acting. So integral from 0 to 3. So this integration is for the entire term. Hence we have mass itself is given as 3. Final velocity you are asked to find out. Initially it was at rest condition. Taking the by part, we have 0 to 3 6 t square dt I cap plus 0 to 3 2 t dt j cap. That's it. So you need to find v minus 0 itself is v, children. This is 3v equals to 6 is a numerical part. Bringing out, we have 6 times of 0 to 3 t square dt I cap plus here to bring it outside, we have 0 to 3. What is left over? T dt j cap. Okay, so I'll just highlight this I cap and j cap so that you won't get confused. So this is a j cap direction. Here it is on x-axis I cap. Okay, so you have to integrate for these two portions. Children, hope you remember the formula for integration. Remember always the integral of x power n dx is written as x power, this is x, okay, so power plus 1, denominator also plus 1. So this formula you need to remember. Variable, x is variable and n is number. So here the first case, if you consider this, this is of the form integration of t square dt, integration of t square dt. So wherever you find x, that is replaced with t. Okay, so instead of x, what is there? T, and instead of n, what is there? 2. So dx means dt. Based on that, let us take the formula. So x power n, so x power n plus 1. T square, so t power n plus 1. This is n is 2 plus 1 whole upon 2 plus 1. So this makes the formula. Okay, so x power n, x power n plus 1, t square t power 2 plus 1. That's it. So this will be t cube by 3. Okay, well here also if you observe the same, we have integral of t dt. Integral t dt can be written as, so x power n, t power nothing means 1. Okay, x power n, t power 1. So x power n is written as x power n plus 1 is a formula. So t power 1 is written as t power 1 plus 1 whole upon 1 plus 1. N plus 1, n plus 1, 1 plus 1, 1 plus 1 equals to, written as t square by 2. So based on these things, let us substitute and try to solve the values. So we have bringing this v the other side, or keeping it later we substitute. 3v is equals to 6 as it is. Integral of t square dt. Integral of t square dt is written as t cube by 3. What is this, children? T cube by 3. That's it. Then what happens to these values? This is lower, this is upper. So this is called lower limit and this is called upper limit. From where to where? So the time acts up to 3 seconds. So starting time is 0. So 0 to 3 seconds. Those values I replaced over there. So when you substitute like this, these values will come the other side like this. So lower limit is 0 and upper limit is 3. Okay, over I cap plus again this 2 into integral t dt. What is the value of integral t dt? It is t square by 2. So t square by 2, and again the same limits. What is that? From 0 to 3 and j cap. That's it, children. Well, so now let us try to solve the same. So observe this. This 3 goes 2 times and 2 gets cancelled. So now you are left with the 3v equals to 2 times of t cube. Instead of t, you have to first substitute 3, again 0. Okay. So that means replace upper limit for t. What is t? 3. 3 cube minus 0 cube. So upper value whole cube minus lower value whole cube, I cap, plus what is left over here? Only t square. But what is upper limit? 3. So replace t with 3. 3 square minus lower limit is 0 square. That's it. Here no other number is there into j cap. So 3v is equals to 2 into value of 3 cube is 27. I cap plus this is 9 j cap. Bringing the value of v the other side, we have 2 into 27 upon 3 I cap plus 9 by 3 j cap. Okay, further simplification gives here 9 times and here 3 times. Hence, the final value for v, final velocity is found to be 9 to 18 I cap plus 3 j cap. 18 I cap plus 3 j cap. So first option must be true. That's it, children. Well, moving to the next question, 24. An impulse I given to a body changes its velocity from v1 to v2. Initial velocity was v1 and final velocity was changed to v2. The increase in kinetic energy of the body is given by. Children, kinetic energy, increase in kinetic energy formula is half m initial final velocity square, okay, half mvf square minus half m vi square, something like this. That's it. So change in kinetic energy, final kinetic energy formula is half mv square. So change means kf minus k. I'll write it like this. Change in kinetic energy is final kinetic energy minus initial kinetic energy. Hence, change in kinetic energy, simply K I'm writing. Kinetic energy formula is half mv square. So, final velocity square minus half m initial velocity square. That's it. Hence, kinetic energy change can be written as the velocities, the changes its velocity from v1 to v2 it was given. Okay. So, final velocity was found to be v2 square and initial was v1, vi initial v1. That's it according to the given data. Hence, change in kinetic energy is given as, let us take out half ms common. Then you are left with v2 square minus v1 square. Up to this it is clear, children. I hope this is clear. Continuing. So, we have delta k can be written as half m into, this is of the form a square minus b square. That can be written as a plus b into a minus b. So, let me write it as v2 minus v1 into v2 plus v1. First I wrote minus and then later I wrote v plus. Okay, a plus b into a minus b. Up to this it is clear now, children. Well, just observe this carefully. Mass into change in velocity. So that's nothing but impulse. Well, so substituting those values, we have change in kinetic energy was found to be half, and what is that, ma? Impulse is indicated with the letter I. So this, the complete value they indicated with letter I into v2 plus v1. That's it. So the change in kinetic energy was found to be, so rewriting in a proper way according to the options we have, change in kinetic energy is found to be, where is that I in numerator, v1 plus v2. Where is I in numerator, v1 plus v2? Here. Minus is not there, plus. So among this, denominator 2 must be there, so option must be here. So let me rewrite this once again. v2 plus v1 can be written as v1 plus v2 I, okay, first I multiplied by v1 plus v2. Denominator 2 is there, so that is by 2. Hence, option 2 must be the correct answer. Okay, children.